Hi, APE students. Welcome to video 22 on soil science. So what is soil? Basically, we're talking about the thin layer of Earth's crust. It's made of minerals. It's made of organic material, leaf litter, all that sort of stuff. It's very important that we don't call soil dirt because it is not the same thing. Dirt is kind of like what's under your fingernails, what you might clean up in your house in the vacuum cleaner. Soil is what we grow our crops in. So it's very, very important that we don't treat it like dirt. Why is it important? Because it does support all life. If you don't have soil, you cannot have life. It's kind of important for us to eat and for animals to eat so that we can eat them. It also stores important nutrients like phosphorus, nitrogen, potassium, calcium, magnesium. It holds water for us. It supports our buildings. And it also filters and buffers and detoxifies water or anything that might be in our water. So how do we actually form soil? The parent material is the stuff that is the rock that originally is going to be broken down. So that is the original rock. It's broken down through weathering and eroding. And these are the 5 things that can cause that weathering and eroding. So your climate is the most important piece. Please make sure you're aware of that. That's including water, wind, the temperature, so freezing and thaw cycles that we get a lot here in North Carolina. It snows one day and then it'll warm up and it'll thaw and then it'll freeze overnight. Biology, animals and plants, topography, are you at the top of the mountain or the bottom? That might determine how fast you will weather. Parent material, what type of rock do you start with? Is it really hard? Is it really soft? And then, of course, time. It takes hundreds of years to form an inch of soil. So looking at the different nutrients that are inside of soil, you need to know macro versus micro, and here's a good chart to have written down. So macro are the main nutrients that the soil needs so that plants can grow. There's primary and there's secondary. So the largest quantities are going to be nitrogen, phosphorus, potassium. Those are things that mainly fertilizers are going to have because that's what the plant is losing first. So you add fertilizer, which is nitrogen, phosphorus, potassium fertilizers. Secondary are still micro, but they don't need, secondary are still macro, but they don't need quite as much as the primary. So sulfur, calcium, magnesium. And then micronutrients are something that you need in very small amounts, and that's probably not going to be that many in fertilizers. So some things that are in soil, bacteria, microscopic worms, earthworms, moles, all of these kinds of things can break down a weather material. Anything that we saw in our leaf litter sample, those are soil organisms. And the purpose of soil is to provide us a lot of these ecosystem services. So it maintains our fertility, prevents erosion, breaks down toxic materials, cleanses water, all of those things why we said it was important. So we're going to look at some physical and chemical properties of soil. The first physical property that we're going to look at is color. So color is determined by the different minerals that are inside of the soil. So if you have hematite to start out with in the parent rock, then when you break that down, the soil is going to be red. A lot of clay has hematite in it. That's one that you should probably know. I would not necessarily know the rest of these. These are just kind of for your information. Quartz, if you see sand at the beach, a lot of it is quartz sand. It can also be calcite. But mainly just understand that the color is a characteristic of the different minerals in it. These are some different variations that you see. There are 20,000 different soil types in just the United States, and these are a couple different ones. And most of the time you can see different soil types with the different colors. So another physical property is texture. This is basically the amount of sand, silt, and clay, and you see the texture triangle down here that we've talked about. Loam, you do need to know, is the perfect soil for agriculture. So it's the perfect mix of sand, silt, and clay to grow different things. You don't need to know the actual numbers, but you do need to know that gravel is the largest, sand, then silt, and then clay is the smallest. So here's again another picture, same thing, gravel, sand, silt, clay. And here is just kind of a funny science joke for you. What did the shy pebble say to the big rock? Do you think I'll ever be a little boulder? There you go, your lame science joke of the day. Hope you enjoyed it. So here's what clay looks like. If you haven't seen it before, it's very, very fine. The grains are fine. You can't really see them. And then here will be coarse texture, which is sand, just like you would get at the beach. So some other properties of soil. Porosity versus permeability. Porosity is the space between the grains of sediment and soil. Clay actually has the most porosity. It's a little counterintuitive. Even though it's the smallest grain size, it has the most space. If you have like the same size cup of sand versus clay. Because the particles are so small, there's a lot of water that can be held in the small spaces between. So there's small spaces, but there's a lot of those small spaces. So again, porosity, the air inside the spaces between the grains is the same thing as what's inside the air, but they're in different proportions. So in the air, we don't have, thankfully, more CO2 than we have oxygen. In the soil, we do because of respiration. And CO2 is going to accelerate the weathering process. You do need to know this formula, how we make carbonic acid. So we have CO2 plus water, and that gives us carbonic acid. And this will increase the weathering rate as well because acids are going to weather things. So permeability is how fast water can travel through the soil. So generally speaking, as you increase the porosity, you're going to increase the permeability. So as you increase the spaces, the pore spaces, you're going to increase the rate at which the water can flow through those pore spaces. So here's an example. You've got sand, silt, and clay. So sand, there's a lot of holes, big spaces. So water can travel through that really quickly. Silt, there's smaller spaces, so the water can't travel as fast. And clay, even though there's a lot of spaces in there, those spaces are so small that they cannot actually travel through to get to the other side. So if you're in a landfill or something like that, you're going to have a clay barrier. Water cannot travel very easily through clay. So porosity and permeability are related to the grain size. We talked about that and how tightly packed the materials are. So this is going to be kind of like your sand picture, your silt, and then your clay. So you notice that there's a ton of little bitty spaces in here, so it can hold a lot of water, but the water cannot actually flow through because it gets trapped and it hits these clay particles. So one more physical property is ionic charge. Soil generally has a negative charge, and you know that positives and negatives attract, and that two positives repel or two negatives repel. So these are called ions in the soil, and if the particles are negative, like they normally are in clay, then they're going to attract soil. Positive ions are going to attract different soil particles like potassium, magnesium. Negative ions are going to repel different particles like nitrate, for example. So this is how you can have these things that are held in the soil as nutrients for plants. A chemical property of soil is going to be the acidity, or also looking at pH. You do need to know this relationship right here. So for macronutrients, they are less available in low pH soils. Micronutrients are less available in high pH. So low pH is anything over here, more acidic, a 0, 1, 2, 3, 4. Rainwater would be like a 5 generally. Less available in high pH will be the micronutrients, and that's going to be up here, your 11, 12, 13, 14. And we can actually do some things to change the pH of the soil if it's too acidic or too basic. So lime is something that's called a conditioner. It's added to the pH. And it can raise your pH from 4 to 5 to about 6 to 6.5, where those nutrients are more available to those plants. So if the macronutrients are less available in low pHs, you want to increase that pH so that micronutrients can be available. So again, soil conditioner is lime. This is not a fertilizer because we're trying to correct something in the soil. We're not just adding nutrients. So it's calcium or magnesium to try to correct the acidity of the soil. And these are some important functions that it does. So it does correct our acidity, it adds nutrients, yes, like a fertilizer does. But it can also do these things like increase bacteria, promote nutrients, reduce toxicity. Another conditioner is compost. It's decayed organic matter. You saw this at the Well-Fed Community Garden. This improves the structure of the soil, so it makes it more spongy and it can hold more water and air can circulate better through it. So we do have some pollution that gets in our soil. Pollution is any change that affects plants and animals, other organisms that are in the soil. The pollutants can move into groundwater from soil, surface water. It can creep into tiny micropores. A lot of pollutants come from fertilizers and pesticides. So the more fertilizers and pesticides we add to the plants, the more we are polluting the soil. Yes, we're adding nutrients, but we're also adding other things. And over time, it can accumulate. So a type of pollutant would be salt that we are adding. So soil salinization, like our lab, comes from irrigated water. that contains salts. And when we take that irrigated water and we add it onto the plant, and then the water evaporates like water always does, the fresh water leaves and evaporates up, and it leaves behind these salts in the soil. So the soil becomes more salty. Sometimes it'll even be like that crusty whitish, which means that has a very high accumulation of salt. And then you cannot plant things that'll grow. You have to have maybe GMO crops that are salt tolerant. You don't want this in your soil. So how do we remediate some of these things if they do happen? Unfortunately, what we used to do is just dig it up and burn it. And as you can imagine, that was not a very good thing to do. We were adding those pollutants to the atmosphere, putting them in the water, also killing anything that was actually in the soil. So here's some good remediation techniques. Dilution would be awesome for salinization problems. So we add lots of water and basically we leach out the salt. You can also do vapor extraction. You can inject air, and sometimes that can get rid of any kind of gases that are down there that are causing pollutants. Bioremediation is using microorganisms to get rid of anything that is organic so they can eat it. And we have phytoremediation, which uses plants to absorb contaminants like salts or heavy metals. So these are all some things that we could do without having to actually burn the soil. And that's it. Be prepared for a quiz tomorrow.